My name is Nathan Moore. I work in the lab as a research engineer. I specialize primarily in the field of asphalt pavement friction. Pavement friction is the interaction between your vehicle tires and the underlying pavement. It's very important as it pertains to safety of public roads. Primarily, there's a strong correlation between increased friction on pavements and reduced crash rates in the field, both wet and dry. So pavement friction is critical as it pertains to safety. Friction is measured using a variety of different devices. However, all of them involve rubber, typically a rubber tire, sliding across the pavement surface. Some devices measure friction continuously. For an entire network, you're able to measure on a very granular level, whereas other devices are more spot checks where you only are checking certain regions or certain locations of a pavement. The most common field friction testing device is the locked wheel friction trailer. The locked wheel friction trailer is a field testing device that involves a rubber tire in full lockup sliding across the surface while water's being sprayed underneath. There's two tires that are used in this test, a ribbed tire and a smooth tire. The ribbed tire has treads in it that give the water somewhere to go, and so that ribbed tire is much more sensitive to the aggregate characteristics in the pavement, something we call microtexture. Whereas the smooth tire doesn't have any treads in it, so there's nowhere for the water to go, and it requires the pavement to do all of the work of displacing that water. Because of that, the smooth tire is significantly more sensitive to the macrotexture of an asphalt pavement. Microtexture is the texture of the aggregates inside an asphalt pavement, whereas macrotexture, think about the peaks and the valleys between aggregate particles inside an asphalt mix. The best way I ever heard this explained is microtexture is something you can feel and macrotexture is something you can see. Friction is its highest a few months after an initial pavement is laid down. That's because the thin film of asphalt binder that was covering the surface aggregates has been removed during the initial trafficking of those sections, but those aggregates are still gritty and have their full microtexture. However, those aggregates will polish over time. Some aggregates will polish more than others, and the aggregates that do polish more than others will have a more steeper friction decay over time, and they will reach lower levels of friction faster than aggregates that don't polish as well. In general though, friction will decay to a point where it'll eventually kind of flatline. And then at that point, it'll vary depending on seasonal effects and random testing noise. Friction can be improved using a handful of different treatments. One simple way is a brand new overlay. However, you can also improve friction using other surface treatments like chip seals and microsurfacing and things like that. One of the premier friction products out there is something we call a high friction surface treatment, which uses calcined bauxite and an epoxy glued to the surface of an asphalt pavement to provide incredibly high friction and a very durable surface. Another option is to use shot blasting. This is where small metal balls are shot at the surface of the pavement and they break it up and they kind of reinvigorate the microtexture of the aggregates that are in place. It doesn't disturb any of the surface, but it revives some of the microtexture in those aggregates that have been polished. So those are a handful of ways that you can improve friction on existing pavements. We've done a lot of work on the NCAT test track looking at the effects of certain types of aggregate on pavement friction. One project in particular, we were able to help a certain agency confirm that their specifications around a certain type of aggregate were written appropriately. We built some test sections on one of the curves in our track using a higher proportion of this aggregate than what would typically be seen in the field. And ultimately, those sections reached a very low friction very quickly. And we use these findings to help them see they do not need to increase their allowable amount of that particular aggregate type in their mixes. We've also done some work in recent years incorporating friction in mix design before sections get placed on the track, where we tried to hit certain friction targets in the lab and then transfer those to the field and see how well laboratory friction results could predict or relate to field friction results, we've had great success doing that, and I feel like very confident that there's a future in that for agencies who want to include friction in a mixed design specification. One of the many benefits of performing friction testing on the NCAT test track is it allows us to conduct experiments that involve friction without having to put public lives at risk.